All right, here we're on the second day. We finished all of our field builds last night. Here we have our amp, our speaker, and our climber. We took a couple of hours to get most of the materials in the morning, and we used our wood shop to cut everything up. It took us a couple of hours, probably 4, to cut all of these pieces. This one with the jigsaw took a little extra time, but not too bad. And it took us probably 3 extra hours just to assemble everything. We have not tested it with anything outside of just making sure that the field element fits and everything. That's not an issue. So yeah, that's our current progress for the field.
So we have our update for this intake prototype. We did some testing now that this morning we got the game piece and testing feeding it through, we found that the angle of attack right here is a little sharp, so the piece liked to bind kind of in this region right here. And then the friction on the polycarb was a little more than expected. So to resolve this, if we were to keep moving forward with this prototype, we would investigate a lower belt system so that it's 2 powered surfaces rather than 1 passive surface, or reducing the angle of attack to allow for a more gradual transition for the note. But we found that in the back region here where the angle of attack is much less, the note slides perfectly fine. It's just this kind of initial contact off the ground is a little aggressive, and moving forward we'd recommend some changes.
Perfect. Okay, so this is our second intake design. This we call the flip arm design. Right here modeled is just the intake itself, but how this would work is it would have 2 arms coming off to a pivot point mounted up here. This one motor spins both shafts through a series of belts and gears, and then we can take this whole unit, flip it up and over, and then feed the ring backwards and into a shooter that's mounted here. This also allows us to go to a 3rd position and then drop the ring out into the amp. That's pretty much how it works.
So this is the current state of our robot. We've got most of the geometry figured out. We're going with an arm that's going to pick up from the ground, and then it can lift up to score in the amp and bring it all the way back to feed it into the shooter. Alright, so this is the layout sketch for our robot. It has an intake down at the front here, and then it's going to pivot around this point here. It goes up, and it'll move the disc backwards out of the intake into the amp, and it'll come all the way around to here and move the disc backwards out of the intake into the shooter. And the shooter will shoot along this trajectory line up into the high goal if we run right up against the subwoofer. And the intake, which is what I've been focusing on, is running off a single Neo, powering a 3-to-1 belt reduction. This top shaft will have 2-inch compliant wheels on it, and the bottom shaft is geared up 1.5-to-1 and is running off 2 gears and a belt. And this will just be covered in some sort of grippy tape, but it'll remain roughly the size of the hex shaft. And so in the main assembly, if you go up here, you can see that the hooks would stick out here over the chains, and then you'd be able to bring them down, and they'd come all the way down over to here. And so our robot would end up hanging at an angle, probably something around there. This pivot here is going to be powered by 2 motors down at the bottom here, and then a chain run up to here and a cross shaft linking them here. And the whole superstructure is made out of this 2x1 box tube, and then some 1x1 with custom gussets we're making. And so the next steps for this is we're going to make one side of this, or both sides of the superstructure, make the arm, and then we're going to test the intake, and we're going to get the controls done for this, as that's what programming's been working on recently as well.